Welcome to the Amphenol webinar series. Brad Brubaker, Amphenol's Director of Engineering for High-Speed I/O Connectors, will present this webinar on our next generation high-speed products and technologies for 112 gig and beyond. We will take questions at the end of the presentation. Please use the raise your hand function, or you can type your question in the question section of the webinar program. Thank you and enjoy the presentation.
Hi everybody, this is Brad, and thanks for joining the webinar today. On today's session, we're going to just be doing a real high-level overview of our high-speed connector portfolio and our next-generation products that we're bringing to market for the latest systems at 112 gigabits. And we'll hint a little bit on what's to come or what we're working on for the future. It's not going to be an in-depth technical presentation, but it hopefully gives you a good idea of what products we currently have or will soon have in the market and where we're headed. So just a little bit of an, sorry about that. Just a little bit of an introduction here. With regards to our products and the markets which we serve. If you aren't familiar exactly with what we mean by high-speed I/O connectors, it's really the external I/O front panel and sometimes back panel I/O interconnect for the high-speed ports. These products are used across communications, data centers, and even some industrial applications, some specialized industrial applications like test measurement and ruggedized switches and things like that for infrastructure within, within the industrial community. But with regards to communications and data centers, communications, a lot of our products get incorporated into mobile base stations, NIC cards, and the different storage networks, switches, routers, as well as then in data centers for the hub switches and servers, really interconnecting all of the elements within the data center. And our connectors largely interface with the standardized optical and passive copper modules that get interconnected with these cables and transceivers within the data centers and the communications infrastructure. Just to kind of give you an idea of some of the challenges that we're all faced with, and I'm sure as system designers, a lot of you are wrestling with these same things. I'm probably not going to tell you anything here that you don't already know or don't already deal with, but these are the things that we really focus on as we're trying to bring solutions for our next generation products. And the things that we really wrestle over, obviously faster and faster data rates, the need for bandwidth continues to keep escalating with streaming and all of these large data files that need to be transferred and stored and shared across various applications. Thermal management, power management, those are very tightly coupled, and with the higher speeds and especially with the latest optics technologies, power requirements are getting even higher, and therefore more heat is generated. And with the more heat generated, then you have to deal with that. And so we are bringing solutions to market that really each one of these problems, whether it's a smaller footprint or trying to maintain channel loss budgets and things like that, all of these things are very interrelated, and they become an integral function of our product designs. One affects the other. And so on the front end of development, we're looking at all of these, working closely with a lot of a lot of our customers, a lot of our partners on multi-source agreement, and MSA working groups to try and optimize our product performance across each one of these challenging parameters as the next generation drives really bigger challenges in every one of these areas. So this is just a really high overview of our high-speed I/O connector portfolio, and this is not just 112 gig products, but this is really our entire portfolio. And you can see that Amphenol's portfolio really is very broad, one of the most comprehensive, if not the most comprehensive portfolio within the industry. Anywhere from the single channel SFP products, QSFP, which is 4 channels, all the way up to the latest and highest density products, QSFP DD and OSFP, which are 8 channel or 16 pair high speed products, which at the 112 gig data rate support up to 800 gigabits per second per port. So really the meat of the focus for today's talk is really, what our connector offering and really high-speed I/O solution offering is for the latest generation of products that are being released into the market for 112 gigabit channel performance. All of our 112 gigabit products are designed in compliance with the related MSA requirements. So we work closely. We have we sit on most of the working group committees, and we ensure not only that our products meet those requirements or exceed them, but we're working on the front end to help define those and really drive the definition of the MSAs to meet what's really required in the market. Our products, we believe, have industry-leading signal integrity performance while maintaining mechanical robustness. And that's a challenge sometimes. A lot of these, especially as products are forced to incorporate things like higher power, signal integrity. There's often a trade-off between density and mechanical robustness and speed, signal integrity, various aspects like crosstalk and return loss. All of those things come into play, and it's really we approach the design of these products holistically. We design with all of these in mind, and we very carefully look at the trade-offs between them and really feel like our products are optimized to give you the best performance in each of those categories. We've got a very broad range of cage configurations and also accessories like heat sink configurations for both front to back and side to side airflow, various heights of heat sinks. We incorporate light pipes into our assemblies as well. And really, these are configurable for each application. That's one of the things that is becoming more and more challenging as our customers and everybody has their own solutions with how they're going to approach, these requirements of, higher power, more heat, higher density, higher front panel density as they approach, and they all have different ways of doing it. And so our solutions become more and more customized for each application. And so we really offer a wide range of port configurations, heat sinks, and light pipes to fit really any application. So we work closely with customers on the front end and provide those solutions on a regular basis for each application. You can see here that our connector portfolio and our offerings, we have offerings in single channel SFP products, as well as DSFP, which is a 2-channel product that's really in the same form factor as SFP, but doubles the port bandwidth density. QSFP products, both single high and double high, what we call stacked products, as well as QSFP DD and OSFP. We have both the single high and the stacked products. Now, one of the things that's a little different as we get into 112 gigabits is that the stacked products, really all of the products, are surface mount products. So you'll see here in the upper right-hand corner, that's a QSFP DD stacked SMT connector. In the kind of middle and the lower side, you can see there's an OSFP stacked SMT connector, as well as the standard SMT products as well. But the stacked connectors typically in the past have been press fit technology, where the connector and the cage are integrated in one solution and pressed onto the PCB at one time. As we move to the higher speeds, the press fit sections don't really support the high signal integrity that's required. And so the stacked connectors now are SMT reflowed as well. They support belly to belly applications. So you can actually go belly to belly stacked, which would be a 4-port high solution. And the connectors are picked and placed just like you would a standard 1x1 SMT connector onto the board reflowed, and then the cages are applied press fit onto the board over top. So that's a little bit of a change compared to where we've been in the past between the standard products, the standard SMT products, and the stacked press fit. Everything is really going in the direction of SMT application. The other thing that really is a change as we get into 112 gigabits is Amphenol is developing what we call OverPass products for all of our high-speed I/O product lines. So OverPass is really an internal cabled solution where you have a near chip connector that is cableized to a cabled port of the front I/O connector. So no longer are the high-speed signals transmitted through the PCB for long distances. We now have solutions where the high-speed signals are brought off of the PCB close to the chipset and cabled to the I/O connector. And so there's a lot of advantages there in loss, keeping system sizes manageable while keeping channel loss budgets, relatively low, so that you can get away from the use of real exotic and expensive board materials. There's a lot of advantages and trade-offs, obviously, but what we are definitely seeing is a trend in 112 gig and even beyond for more and more OverPass products being developed. And Amphenol has typically in the past had a pretty large offering of internal cables, particularly in storage systems with disk drives, products like Slim SAS, Mini SAS HD, Oculink, MCIO. But we've now developed a product offering around the external front panel I/O with internal cables. And specifically, my organization is responsible for these OverPass products to the external I/O. And I'm also responsible for developing the near chip internal connectors as well to support those products. So we provide a full solution. And the two major products that support the higher speeds of 112 gigabit and beyond are products we call DensaLink and Micro Linkover. They're both shown here. The Micro Linkover is in kind of the center of this picture, right underneath the chip-to-chip heading there, and DensaLink is shown here. That's linked to a stacked QSFP DD port. But these products were designed, first of all, with signal integrity in mind to support 112 gig and beyond, with density, with height, for applications that get close to the chipsets, for low profiles, so they can go under heat sinks. You know, all of these things were taken into account. And those are really our flagship products for these high-speed applications. So this really shows a broad offering, and I know we're making this file available to everybody who's on the webinar today, who's participating, and to anybody that goes to our website. And I just encourage you to take a look at this. There's a lot of configurations here, and there's a lot of possibilities, but keep in mind that pretty much any near chip connector can be connected to any front IO connector. And so you can see we have quite a large variety of options that will fit just about any application and speed that you may have for ASIC to IO applications, also chip to panel applications, riser card, chip to chip. We really have solutions that will support everything that's needed from a system design perspective. Specifically for the high-speed IO connector group, this is really our portfolio for OverPass products. And you can see here we have offerings on the external side with SFP, QSFP, QDD, and OSFP. Our bulk cable is also within the high-speed IO organization. And SpectraStrip has been has a long history of providing high-speed twin-ax cable, which is used in all of these OverPass products. And right now the bulk cable that we use, or the individual pairs that we use for these cable assemblies, really is supports a bandwidth really beyond 112 gigabits, even into 224. So it's it's a really flat performing cable out beyond 40 gigahertz, and with excellent insertion loss and mode conversion performance as well. And then on the near chip end, as I mentioned, the two highest performing products we have are the Micro Linkover and the DensaLink. Both of those come in a 16 pair tooled offering right now. However, we do have a roadmap that shows various configurations of those connectors expanding to 32 pairs, 24 pairs, common IO counts within the front panel IO as well. So the Micro Linkover is really a low profile connector. It's less than 5 millimeters in total height, and it is a direct mate to PCB. So it's a compression type connector with superior SI performance. Literally the connector interface between where it contacts the board to where the wires terminated is about it's less than 2 millimeters long. So it's virtually invisible on like a TDR plot from a signal integrity standpoint. Excellent, very low crosstalk, low reflections. It's really a good performing, excellent performing connector with low profile, so you can get it close to the chipset underneath a heatsink. The DensaLink is a connector that was developed to kind of partner with the Micro Linkover. Some of the feedback we got from the Micro Linkover was that some customers were looking for something that was a little more dense, and some preferred a more traditional interface where they didn't have to have gold on the PCB, or OSP something that could be mated to a contact. So this is a two-piece connector where you reflow an SMT, a small SMT connector onto the PCB, and then the DensaLink cable comes in and plugs into that connector. It's still fairly low profile. It's about 8.5 millimeters high for a 16 pair configuration. It does support 112 gig performance and beyond. It's very high density. It's over twice as dense from a surface, from a footprint standpoint to the micro link over. But it is a slightly longer interface, so the signal integrity isn't quite as good as the micro link over, but still very capable at 112 gigabits. And then I wanted to spend a little time just talking about maybe where we're headed next, which, you know, somewhat in 112 gigabit systems, but really beyond to 224. There's a big trend to not just have IOs that can be placed close to the chipset for you know, very short lengths of PCB traces, but you know, in the next generations, it's looking like a lot of applications, a lot of people are looking to put the IO directly onto the package. And you know, for this, we've been involved with several you know, chip manufacturers, and really working on solutions that we call, you know, direct to package solutions that eliminate the effects of BGA footprints or LGA sockets that the chipsets get mounted to, coming directly off the package. And you know, obviously the focus for this is to be as dense as we possibly can, get as much as we can on there. We have solutions that we're working to support 1,024 pairs on 120 millimeter square package, and actually even slightly smaller than that, somewhere between 100 square millimeters and 120 square millimeters. But you can imagine there's lots of other things, challenges with these types of things, but we are building prototypes now. This concept would be direct to package, so there would be no mating connector on the board. The contacts from the cable would go right to pads on the package itself, and then direct cabling to the front IO ports, like an OSFP or QSFP-DD, QSFP connectors. And as I mentioned before, you know, in the design and the development of these technologies and of all of our connectors, we really take a real holistic approach. So I wanted to just share a little bit about, you know, our capabilities within Amphenol, in terms of, you know, our engineering capabilities and what we can do for you as our customers to provide you with support in system level designs and finding solutions that will meet your needs at 112 gigabit and beyond. And so, you know, within my team, we have, you know, engineers that perform full signal integrity simulation and analysis, measurement analysis, connector only and full channel modeling. So we not only can provide you with S parameter models of the connector, but we can help model your channel. To go along with that, we also are able to provide PCB routing, you know, layouts, and a lot of times we help the customer through simulation come to an optimized footprint and breakout for their connector, and take a look at what that looks like in the full channel of their system. We have full signal integrity measurement characterization capabilities. So once we make the products, we develop the mated test fixtures, the module compliance boards, and the host compliance boards that are used to measure the performance of the connectors, but also measure the performance of the connector within the system. And you know, we design those for all of our products in compliance with the MSAs, and do offer those as a service to our customers for loan or purchase for their own evaluations as well. I also mentioned, you know, thermal is a big part of our solutions, especially when it comes to the latest, where higher power and higher density are required. We work closely with a lot of different vendors on customized extruded and zipper fin style heat sinks. We have solutions with embedded heat pipes and cold plate solutions. We have, we're working on advanced coatings to reduce thermal resistance of the interfaces between the heat sinks and the optical modules. We have our own internal wind tunnel testing capabilities to be able to set up and prototype and test the performance of our solutions. And on the front end, we also have full thermal simulation capabilities. We have the ability to do things in FlowTherm and IcePack. And so we provide all of these services to our customers and work very closely on the front end to ensure that the solution we're providing will meet your needs as a customer and as a system designer. As I mentioned before, a lot of our solutions, our connector and cage solutions, are customizable, and a lot of them are custom to the particular applications. And of course, we have a full suite of testing and simulation capabilities on the mechanical side as well, with finite element analysis, as well as full environmental, electrical, and mechanical test labs in most of our facilities, in most of our engineering facilities, where we can test the entire life reliability of the connector through temperature life, shock and vibe, all within our facilities. The environmentals like mixed flow and gas, we're able to do right here in our engineering facilities as well. And then lastly, I have one more minute here. Just wanted to kind of let you all, if there's any questions that anybody has, there's a direct link here to our website, both for our connectors and our OverPass solutions, as well as our marketing team. And you can see there that there's the product responsibilities for each of our product managers are listed along with their contact information. So if you have specific questions about specific products, you can contact those individuals directly. So I think that's about it. I think we're going to open it up for questions. Lori, do you want to facilitate that aspect?
Sure. So we do have one question, Brad. The question is there a minimum on these custom cables?
Minimum quantity on the custom cables?
Yes.
It depends on what's being customized. Obviously, certain things are able to be customized easier than others. Things like length, obviously, is customizable fairly easily. So if you're talking about needing, a different length of a given cable, certainly we can do that. Pinouts of cables are somewhat easily customizable. But then when you get into different heat sink solutions or a special size of wire or something like that, it could be a little more difficult. So they are customizable. It depends, and I wouldn't say there's a minimum quantity, but it really depends on what aspect of the cable you're looking to customize. And so that's something that, if you contact Vishal, he could certainly answer any questions you have with that.
Okay. Another question, how do you define belly to belly? Adjacent on the same side of the PCB or on opposite sides of the PCB?
Yeah, when I referred to belly, I would talk about an application where you have connectors directly mounted on the top side and the bottom side of the PCB, so top to bottom. Most of the products we have too can be mounted side by side as well, and the minimum pitch of those connectors are really defined within our data sheets, our product drawings that show how tightly they can be spaced side by side. But yes, when I refer to belly, it's top to bottom mounting on the PCB.
Those were the only questions I think we had.
Okay, great. Well, I thank everybody for your time
Uh,
today.
Brad,
And
one more.
yes,
Any information you can share on EXD224?
EXD224. Well, what I can share is that our latest technology of cable is a co-extruded doublet, so to speak, where we're co-extruding the two wires in the pair. They're closely coupled for good, common mode performance. And it really boasts, I believe it's about a 15% decrease in loss over the previous generation dual extruded or single extruded cables, the common technology where you've got, each a single conductor, them being brought together in a twin ax pair. It provides about a 15% reduction in insertion loss as well. So it's high temp, designed for applications up to 105 degrees C. So when we get closer to the chipset and heat sinks, the cable's designed to withstand those higher temperatures as well and continue to perform.
Great. I think that's the last question.
Okay, great. Well, thank everybody for your time today. We do anticipate follow-on presentations with more specific technology developments and products. So stay tuned for those, and thank you, everybody. Stay safe and healthy.